This video is going to cover how to find the geometric mean. So we're going to review reducing radicals, how to solve quadratic equations, and how to solve proportions. So the first thing we're going to do is look at reducing radicals. You have what's called a square root. Now inside the square root, we'll find a number called the radicand. And sometimes you'll have a number like 25. And 25 we consider to be a perfect square. All right, so if we take the square root of 25, our answer is an integer, which is 5. And the same goes for other perfect squares. We have the square root of 4, which is also an integer. It's 2, so we consider 4 to also be a perfect square. Other perfect squares that you should know, 9, 16, 36, 49. And all I did to find these perfect squares was take a number, an integer, and square it. 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. Now we're going to look at some other numbers that are not perfect squares. So numbers like 10, that is not a perfect square. And if we try to take the square root of 10, we wouldn't be able to solve it unless we had the use of a calculator. We could always approximate using our calculator, but what we'll always find is that the square root of 10 is going to be an irrational number, as opposed to when we ended up with an integer, which is a rational number. All right, so some radicals will be simplified. Now, the square root of 10 cannot be simplified. When you try to simplify a radical, your goal is to find a perfect square that's hidden in the factors. So factors of 10, well, 5 times 2 is 10. However, 5 and 2 are not perfect squares, so it wouldn't make sense to reduce the square root of 10. So this would be our final answer in terms of this radical being simplified. So we're going to look at a couple of other examples. And I know you've seen these types of problems being done before. We're just reviewing. The square root of 12. Now again, I'm not going to, I know 6 times 2 is 12, but I'm not going to reduce it to 6 and 2 because those are not perfect squares. When you look for factors of 12, your goal is to find one factor that happens to be a perfect square. So I'm going to choose 4 times 3. 4 times 3 is 12. And the square root of 4, well, 4 is a perfect square, and the square root of 4 is 2, and we don't know the square root of 3. So this is the square root of 12 reduced down. So that's your goal here. Always reduce by perfect squares. Last example, I'm going to give you the square root of 75. If we reduce this, we have 25 times 3 is 75, and the square root of 25 is 5, and we don't know the square root of 3. So this would be our final answer in simplest radical form. All right, so now we're going to go back and solve quadratic equations and solve proportions. I'm actually going to do 2 examples in one. Here's a proportion, and we're going to use the cross product property to solve this. So let's go ahead and cross multiply 8 times 3. This gives us 24. And on the other end, we've got k plus 3 times k minus 2. And what has to happen is we're going to use distributive property. Sometimes teachers abbreviate it as FOIL, first, outer, inner, and last. So let's go ahead and distribute k to both terms there. And we end up with k squared minus 2k. And then we'll go ahead and distribute the 3 to both terms. And we'll end up with plus 3k minus 6 on the right-hand side of that equation. The left-hand side is 24. Now we see that this is a quadratic equation. We see the k squared here. This indicates that it's a quadratic equation. We want to make sure that this is set up as ax squared plus bx plus c equals 0. We want to set this equation equal to 0 so that we can factor and then solve this problem. So let's go ahead, combine like terms before we move the 24. So we have 24 equals k squared plus k minus 6. And now we'll go ahead and subtract the 24. And now I have 0 on this side and I have k squared plus k minus 30. Okay, your goal now is to look at this trinomial and factor. Think of what multiplies to give us k squared? Well, that's going to be k times k. And what multiplies to give us a negative 30? What are my factors of negative 30 that will add up to be the middle term? So I can think, well, 15 times negative 2 is 30, but 15 minus 2, when I add those together, that gives me 13. So that's not it. Then I'll try 6 times negative 5, and 6 minus 5 is a 1, and I see I have a 1k here. So it looks like these are our factors. So we'll go k plus 6 and k minus 5. Now these factors together are set equal to 0, so we're going to go ahead and separate those factors. We have k plus 6 equals 0, and go ahead and solve that. And we get k equals negative 6. And on the right, we have k minus 5 equals 0 as well, and add 5 to the other side, and you get k equals 5. So for this problem, we have two solutions. Now this is called a solution set. We're going to put the smaller number on the left and 5 on the right-hand side. These are not parentheses. These are called braces. Okay, solution set. Now you can always go back, plug in, make sure that they both work out. They both check out. We have negative 6 and 5. All right, both of those values will check out. The only time this will be undefined is when k is equal to 2. So we're all set. The solution is negative 6 and 5 for the value of k. Those are our answers. All right. So now we're going to get into geometric mean. Geometric mean is also referred to as the mean proportional. Okay, it's the square root of the product of two numbers, which we call the extremes. So go ahead and write this down. Take a minute. All right. So what we notice is that this number and this number, those are called the means. And if you notice, they're both the same. So if we had a proportion where I had 1 over 2 equal to 2 over 4, notice this number being repeated. That number being repeated, that's called the mean. So we say 2 is the mean proportional between 1 and 4. Now this proportion is true. Okay, I'm going to give you another proportion that's true. We have 1 over 2, 1/2, is equal to 5 over 10. This is a proportion, but there is no mean proportional because there is no number being repeated as you cross multiply. All right, so in these next examples, you can simply cross multiply and see if you have any repetition of numbers. The means here are different, so there's no geometric mean. On the next example, these numbers, you see the repetition of the 4, there is a geometric mean, and we say that 4 is the geometric mean between 2 and 8. All right, and for letter C, we say that 2 rad 5 is the geometric mean between 2 and 10. And lastly, there is no geometric mean in letter D. So we're looking essentially for repetition of numbers in this spot and this spot as you cross multiply. And that number we consider to be the geometric mean. So I'm going to show you a couple of examples. The first set of examples, the geometric mean is missing, and in the last example for today, the geometric mean has been given. So let's look at this setup. We have these series of examples, and the directions say to determine the geometric mean of the two given numbers and in simplest radical form. So let's go ahead and set this up. The geometric mean is missing, so this number that belongs in this spot and this spot in the proportion is missing. So we want to find it between these two given numbers of 4 and 9. So we have to solve this problem. It's a proportion, so we'll use our cross product property, and we'll get x squared equals 36. Now to solve this, we take the square root of both sides. Now when you take the square root, this is a quadratic, when you take the square root, you have two answers, x equals 6 and a negative 6 as well. All right, so when solving equations, you get two answers. Now in geometry, if this is applicable to a triangle, just make sure that you reject the negative and your answer would only be a positive 6 if this is in reference to side measures. Since this is not a triangle problem, we're going to leave our answer as x equals a positive 6 and a negative 6. So again, this means you have a positive 6 as an answer and a negative 6. You have two answers. in this quadratic equation. Let's go ahead and look at letter B. You have 5 and 20, and you're trying to find the geometric mean or the mean proportional. So let's go ahead and set up and say we're looking for the number that's missing in these two spots between 5 and 20. We cross multiply and we get x squared equals 100. All right, and you take the square root and x equals a positive minus 10. Now what we're going to do is we're going to do a check. I didn't do a check in the first example, but I'd like to show you the check in this second problem. So our check, we're going to make sure that 10 here and 10 here check out. So let's go ahead and look at that. They both reduce down to 1/2. You cross multiply, it checks out. Let's go ahead and check out the negative 10, make sure that also works out. And this looks good as well. We get negative 1/2 and negative 1/2. Or if you cross multiply, you'd get a positive 100 and a positive 100. So this also checks out. So you see we have two answers that work for this problem. All right, for letter C, we're looking at 4 and 16. All right, so we take x. We're looking for the geometric mean. And we put 4 and 16 here. Now 4 and 16 are called the extremes. All right, and the x here is going to be called the geometric mean. We cross multiply, we get x squared equals 64. And go ahead and take your square root, and you have x equals a positive or a negative 8. Again, two answers. All right, now letter D and E, what happens when you cross multiply here? Let's set this up as 8 over x equals x over 9. Cross multiply and you're not getting a perfect square. 72 is not a perfect square. So what do we do in this situation? We're going to simplify, put this in simplest radical form. Now, as I take the square root, I'm not going to forget the plus minus radical 72. Now I think of factors of 72, one that might be a perfect square. Now 8 and 9 might come into mind first, but since the 8 can continue to be reduced, 9 is not the largest perfect square here. So what we're going to do is look for other factors of 72. A larger perfect square would be 36, and 36 times 2 is 72. So if you did initially think of 8 times 9, you're not incorrect. You would just have to simplify further. So it takes you a little bit longer to work it out that way. The square root of 36 is 6, and we don't know the square root of 2. So this is our final answer for letter D. All right, let's look at letter E. We've got 10 and 14. We're looking for the geometric mean between 10 and 14. Now, it doesn't matter if I set it up like this or if I put the 14 over x equals x over 10. All right, so either setup is fine. Your main goal is to find the geometric mean, which is the number that should be placed here and here. We cross multiply, we get x squared equals 14 times 10, which is 140. And so now we're at the point where we want to solve this quadratic, and we can take the square root of both sides, and x equals positive, negative, square root of 140. Now 140, let's go ahead and reduce that. That's going to be 4 times 35, and the square root of 4 is 2, so our answer is plus minus 2 radical 35. All right, and the last one, you're going to find the geometric mean between 4 and x minus 1. So our setup, 4 over x equals x over x minus 1. Now let's go ahead and cross multiply here, and we get x squared equals 4 times x minus 1. Use your distributive property on the right-hand side, and you'll have 4x minus 4. Now we see this is a quadratic equation, and so we want our format to be ax squared plus bx plus c equals, you guessed it, 0. So let's go ahead and do that. I'm going to go ahead and move this to the other side. So I have x squared minus 4x. Also add the 4 plus 4 equals, nothing left, that's 0. So now we're going to go ahead, as long as it's set equal to 0, we can go ahead and factor and solve this problem. So factors of x squared, we have x times x. And factors of 4 minus 2 minus 2. It looks like we have a double root here, which in the end is going to lead us to one answer. All right, so x equals 2. You're going to solve that left-hand side and get x minus 2 equals 0, and the right x minus 2 is also equal to 0. And you have one answer. That's our double root. So one answer, x equals 2 for this last problem. All right, so one more problem. This question, the mean proportional between two values is 8. So they already gave you the geometric mean. They gave you the geometric mean as 8. So remember where the geometric mean is placed. It's placed in this spot and this spot. All right? If one of the values is 16, and we're supposed to find the other value. So notice in this question, it's different from the first set that I gave you where I asked you to find the geometric mean. In this question, I'm giving you the geometric mean, and again, they get placed in this spot and this spot. So let's go ahead and cross multiply. We've got a linear problem going on here, and x equals 4. We're done. All right? If you have any more questions, please let me know.